Good
Good
morning,
morning. I'm Rich.
Addison,
Hi.
Yolanda, Jane. Nice to see you all.
See you. Nice to see you.
How is everyone? Yeah, good.
Excellent.
Well, I see the room still empty. People are still coming in, I guess.
Manesh, you want to
That's
try your sharing slide? Because I got that your slide quite already long. Have you submit a new
Uh,
version?
no, I haven't submitted a new version. Should I? I can put it on Data Tracker, right?
I upload them already to the data tracker.
Okay. Let me send you the latest version, the trimmed
Uh,
down one.
if you have the latest version, maybe you can uh presenting by sharing the screen from your side.
Yes,
Okay.
yes, can do that.
Okay, I think it's time. Okay, let me start the session. Okay, good morning, everyone. Welcome to the GAIA research group. So my name is Addison. I've been the co-chair with James and Curtis. So unfortunately, so the James and another co-chair we could not come here, just only me. And then all the speakers as well. I think with some visa issues and some kind of travel arrangement. So we all the speaker will be remotely participant. So anyhow, so please welcome. Okay, so just the protocol before starting the session, we have the a note well that I might repeat again. Okay, so the note well by participant participating in the IETF, you agree to follow IETF process and policy. This note well is a reminder of some of those policies. So for a links version for the next, please visit the IETF note well in this URL or using the QR code below. So for IETF participants are expected to behave in a professional manner and extend respect and courtesy to their colleagues at all times. So more detail, you can see looking to the IFC 7154. And if you have any concerns about behaviors, or please contact the Buddhism who have duties and confidentialities and extensive power to act as set of in IFC 776. So if you are aware that any IETF contributions at the five mentions in the IFC 33 78, so it's covered by the patents or patent application that are owned or controlled by you or your employers or your sponsors. So you must disclose that fact or not participate in the discussion. So more detail, you can see the IFC 81 79. So intellectual property right in ITF technology. So for detailed process information, please consult IFC 2026 Internet Standard Process and IFC 2418. So lastly, for the ITF routine makes public written audio, video, photographic record of ITF activity, including your personal information as set out in the ITF privacy statement. Sorry, I think microphone is not being quiet. So for advice, please talk to working group and all area directors. Okay, so some kind of the tips. So for the in-person participants, make sure that you sign in to the session data attackers or scanning the QR code in the session. So and use Meet Echo. And then if you want to have questions or just client to the join into the queue, show hands and then keep audio and video off if not using the on-site version. Okay, for remote participants, so please make sure that your audio and video are off unless you are sharing or presenting during the session. And use the headset is strongly recommended just to protecting some noise and so on. So for all participants, state your names each time that you begin speaking in the queue. Okay, so for more resources for IETF 125 Shenzhen, so you can look into the agendas or for Meet Echo for the other information. And also, yeah, if you have any kind of need technical assistance or see reporting issue page here. All right. Mm-mm. I could not click on my.
Testing, testing.
Ali, we can hear you.
All right, great.
Hi, Polly. Finally,
Yeah, I
yeah,
managed
okay.
to, and I know what's wrong because I registered originally using my NTU email address, but my data tracker account is my Gmail address. Okay, but it's okay. Thank you for sending me the fee waiver link again. So I registered using my Gmail this time, and it worked.
Okay.
Oh, sorry, I have some problem because I cannot control. I cannot control the slide. Just let me try some technical issue. Mm. Mm-mm. Oh, I get it out from.
I can help you, Adesorn, from the remote side. Which slides are you trying to show?
Yeah, Jane, can you share the slide because I think I was kicked off from the data taker somehow.
Okay, which slides?
The first one, the share
The GAIA
session.
slides.
Yeah,
Yep.
introduction.
Okay, give me a sec. Okay, same problem. I'm having the same problem, so give me a sec. Are you in Data Tracker, Adeswarn?
Yeah, but I think my session was like freezing right now. So okay, I try to restart my browsers. So can you share the slide right now, Jen? I think.
No, it's not letting me. I'm
Okay.
not sure why. Manage slides. I'm just trying to. Nope. That's strange. Sorry, everyone. Give us a second. And if do you have them on your laptop, Adeswarn? Because you could just share. Yeah, there you go. Okay.
Jen, I'm back to control. Get the token.
Bravo. Yep.
Okay.
Go for it. Yep.
Okay. All right. Sorry for some technical problems. I think okay. So I think the previous year was in the last slide already. Anyhow, so the agenda for today. So we have the 5 speaker lined up. So the first one going to be Leandro's. So Leandro will present his draft on the GAIA circular divide practices. So Leandro has already submit the draft to the mailing list for some time. I think it's about since last December, and then he also releasing some revises as well. So he will present like what, and then so we might need the rooms and audience here, and then participant in the remote for the call for adoptions. And the second speaker will be John Robert Mendoza from Philippines, DOS ASTI. So he will presenting the hands-on experience of connecting the unconnected on the community network uh, in Via here. Sorry if I spell it quite long. It's Via here in Philippines anyhow. And then the third slot will be Polly Huang. We be happy to have you here from NTU Taiwan. So she will present the study on the Twitch CDN as an ecosystem. So that's kind of a long-term project that she has been working with her student for some time. And the first slot, we have our old friend, Jonathan Brewer from Telco to New Zealand. So he will present his new tool on the local network demand, supply, and financial application planning apps. Lastly, we have Amalesh from ISOC. So he will talk about the backout and buyout, assessing internet infrastructure's resilience under power grid failure. So okay, so just been in time. So I will pass my token to Leandro.
Thank you very much. And I will request my slides.
Sure.
Okay, so thank you. Good morning, good evening, whatever. And well, a great opportunity to join you. So this presentation is related to an internet draft that is called Operational Practices for Digital Sovereignty and Meaningful Connectivity through Circular Management of User and Network Devices, a long title. And it's an experience based on different initiatives. In Spain, it's called e-reuse with different locations, COA and TAO, which are two organizations in Argentina and one Hahatai in Senegal. And we've been discussing the document in the GAIA list, and then, well, I prepared a new version that including feedback from all the emails from the people in the group. So the idea is to see to what extent this is mature, or we want to adopt this discussion and improve it, or eventually maybe approve the document. So Regarding the motivation of the work, well, you know that typically we look at in connectivity deployments to network infrastructure, assuming that people already have devices to connect to. Since connecting to the internet is not a kind of natural capacity of humans, we need devices to do that. And then, well, in some communities, in many communities, perhaps it's there is another barrier, which is that in order to enjoy a meaningful use of the internet, you need to have proper devices. Sometimes network devices to get close to the network to you, or use the devices to interact with it. And then, well, these might be unavailable, unaffordable, broken, difficult to repair locally. And then, well, connectivity is not just enough. And then, typically, it's difficult to find skills in repair, but also spare parts. And as long as this happens locally, things are more easy to use. Um, and well, when we talk about the concept of meaningful connectivity, meaningful, useful for the person or the community, and also the ability to decide and manage the maintenance or availability of devices. This is connected to the concept of digital sovereignty. So we look at device, let's say the device ecosystem is a critical part of the connectivity system. So what in this document we do is we look at different operational practices done for a number of years and in real deployments, and then in all of them, let's say availability of devices, managing devices, network or user devices is part of the connectivity infrastructure. And then, of course, we have looked at the how to manage, let's say, reuse of devices. Typically, in many cases, come from donations from out-of-use devices from private and public organizations that are adopted by different communities. And then, of course, repair is another issue. Or how do you, let's say, provide a device that is no longer used by one person to another person, so they can have meaningful use, whatever it is. And then, well, it is an informational document. There's no protocols or anything beyond that discussed. And the evidence is what I mentioned before. Several communities in Spain. Spain is a developed country, but you find, let's say, global south communities in the global north as well. ECOA is a university cooperative that provides computers for students that do not have the income to have one, but they are in many cases studying computer science. And of course, without a computer, it's very difficult to follow the courses. Tao is working in a recycling plant and refurbishment plant in some communities which are around the Rosario city in Argentina. And Senegal have some different diverse initiatives with about digital inclusion. So they are quite different, but there are common traits among all of them. And then in the document, you will find, I will not read them all, but you will see that there are some short and sometimes more longer discussion about concepts like meaningful connectivity that, depending on which sources you consider, it has different aspects included. But typically, as you can see, for instance, this is more close to the ITU definition, in which access to devices, I mean, the ability of these devices is one of the ingredients among others. Also, digital sovereignty, this ability of communities to be self-supporting, self-sustaining, how devices are managed typically in community networks, maybe you don't provide a device for everyone, but maybe you can share a smaller number of devices across people depending on their needs. So if you don't use it, you can return it and get it back when you need it. This is called collective access sometimes, is that the ownership of the devices is not fully on the end user. And then the end user enjoys a device when it's given. And there is a Latin term called comitatum, or loan for use, in which that defines how this can be formalized, this kind of loan contract. And in the end, the objective is that when the device is no longer usable by anyone, at least you need to be responsible for giving it back for recycling, or recycling it yourself and prove that you did that to prevent environmental damage. And then among all these experiences, we have seen several principles, and this is a kind of a collection of principles that were observed in multiple, or maybe in all operational practices in different degrees, adapted to the local rules or needs. So you can see that this dual device availability together with connectivity, some degree of local repair capacity, some degree of sharing devices, community ownership, some degree of also of transparency data, so that you cannot manage something you don't know. So you need to keep track of, to some extent, of allocation of devices. You need to keep track of quality of refurbishment sometimes, or things like that. There's also a combination of sustainability, I mean, something related to environmental sustainability, but also economic and social. Some social inclusion policies related to access to devices. When you reuse, you have to be sure that you are not affecting the privacy of people and their data. So you need to be careful with data wipes and data collection. Well, the community takes care of the environmental responsibility, because devices, when they become waste, they can be problematic. And well, some more kind of how governance works in the different communities, that is typically different and based on traditions and practices and so on. So in the document, there's also a specific description of operational practices, like as you can see here, this is a list, and maybe I will not go. They are connected to the previous discussion on principles. Principles translate into practices, and practices can be grouped into these categories. So the document describes each of them. Just to mention one, for instance, secure data sanitization and proofs of data wipe are important, because you will not donate or share your device unless you have a proof that it's impossible that your personal data is leaked when the device is reused by someone else. And then when that is done, there is a proof, documental proof, can be paper-based or digital-based, that this process has been done before the device has been given to someone else. And the same for collective access, I mean, rules to borrow or obtain devices. So the document also discusses different aspects like human rights implications, because, well, there's the HRPC working group that developed several RFCs, and well, it is connected to human rights, and in the document it describes that into more detail. And there are also discussions about, well, security and privacy, and to what extent this can be ensured, even though devices are shared. How to keep them, their integrity in the software, in the firmware, in the hardware, of course, and also the implications for sustainability. I mean, connecting more people doesn't mean that we are damaging the environment more. but that there are ways to ensure that e-waste is managed, that by reuse, we might reduce the amount of resource extraction, mining, for instance, and how that reuse and repair can become can create jobs, can create income for the community, and develop skills. Local skills are very handy. And well, how do we connect the environment and connectivity and avoid that improving one we damage the other? And then, well, in the document, there are more details about how these device ecosystems can be useful. Oh, yeah, and by the way, you will find also a detailed description, well, or some details about each of the cases, and a bit of comments about how to replicate that experience in new communities. And finally, there are some reflections that I think they are kind of introduced before on what we have observed or what we could learn by looking these or other operational experiences and learn patterns which are applicable to other communities or deployments or ecosystems or whatever you want to call it. And to me, what was interesting is, well, I wanted to know from you if you find that this scope of looking at, let's say, community connectivity together with device access is appropriate for Gaia. If you think about other architectural considerations related to these life cycle practices, if any additional deployments should be included because they bring some new dimensions, or the list is okay as it is, and then to what extent a document that was developed by several people involved in these communities can be adopted by Gaia and moved forward along the process of becoming, let's say, a Gaia document that is consented by at some point by Gaia and maybe follow the formal path of adoption. And just to finish, well, this is the list of, let's say, supporting organizations that have contributed to develop the software and the practices and all the ingredients that are mentioned in this document. And there are two pictures, one of on the left, one community center in a villa in nearby Rosario that is equipped with these refurbished devices. And on the right, this is a picture of the Tau workshop where they collect these computers which come from donations that are refurbished, prepared for reuse, and then brought to these villas, to these community centers. And this is one example where you can see that there is connectivity, but also there are laptops being used by those from those communities. And that's all from my side. I leave the questions in case that you want to comment on that or anything else. Thank you.
Thank you, Orlando. So we have Mallory in the queue. So
Hi, everybody. Mallory Nodal. Thanks so much for this document. I think it's definitely appropriate to try to articulate the value that drives these projects. And I think you've done a really good job of elaborating all of the things that community networks and the many participants of Gaia over the years organize around and why they do what they do. I guess it's maybe a question, but also a suggestion. So I think the term digital sovereignty gives me some pause. It's used a lot. I think it's typically in conversations in contexts that are about economics. So digital sovereignty is meant to evoke economic protectionism for local, national, or regional markets. that are tech in nature. So, we had local telecommunications companies all over the world in the early days of the internet, and now these quote over-the-top services that are global have exploited those local networks and locked everyone in to like multinational digital servitude, basically. I mean, I think that's roughly what a lot of people want to evoke when they talk about digital sovereignty. And I'm not sure, I think your draft and what you're trying to articulate is just so much bigger than that idea. And I would say, looking at places where you've used the term, the title notwithstanding, but like actually in the text, I think you're better served by just saying the words without trying to characterize that as digital sovereignty. Like, independence. You can get specific about independent from what. Is it independent from, like, imagine in a location you have people who repair devices, people who provide connectivity, people who have like installed and created software and run it on local servers, that sort of thing. That dependency is probably a good thing, but maybe what you want independence from is some other like outside entity, right? It's not that entanglement is bad. It's maybe yeah. So in that case, you would want like community independence for the economy, right? Or autonomy is another word I think that you use that's probably better to describe what you mean than digital sovereignty. Autonomy, you have agency over the technology, meaning someone can modify the code, right? And if you kind of bundle these ideas under a banner of digital sovereignty, it actually obscures, I think, what you want to be able to say. So I guess I'm trying to convince you that you shouldn't use that term, but maybe it would be useful to actually, try to be as specific as possible about what you mean as it relates to tech in communities, and then maybe mention how it does tie into this bigger, like, economic protectionist idea of digital sovereignty for the benefit of helping outsiders who maybe don't understand Gaia, but do understand this push in regions like Europe and so on to achieve digital sovereignty. Like, the one way they can actually achieve that is through this litany of practices and approaches. So you can make the connection, but I wouldn't rest the draft on that concept, because I just think you're doing something that's very tangible, and I think digital sovereignty is a very intangible idea. Okay, sorry, that was long and ranty, but I hope it was well received, because it was, I think, meant to make the draft better.
Yeah, it's a very useful contribution. For instance, I took a careful look at the concept of meaningful connectivity, because there are many sources and they are not completely the same, but there are multiple views, and I found that it fits well with what we wanted. I mean, this use that is beneficial for the people and the community, like what people do in schools or hospitals in some of the cases we've been working with. But yeah, I mean, I appreciate your comments on digital sovereignty. I'm not a native speaker, an English native speaker, and I agree that the term is already overloaded by many aspects which are not central to the document. Autonomy, I like that one. I was also thinking about self-sufficiency or self-reliance, but in the end, it's more operational. It's like saying, if you cannot repair devices in your community, it means that you might need to send it somewhere else. Or if you don't know how it works from inside, well, many things are not feasible locally, so you should be able to know how to do that. That is typically common in community networks, that you know how to deploy, you know how to operate it, you know everything you need to make sure that it works for you and it works all the time, and it's reliable and so forth. And we've seen that also in many cooperation for development projects that we have done with students from our university, that they go there and help. But it's very important that the local community knows exactly what to do and have all the resources. They do not depend on third parties, because as soon as they don't know what to do, the network collapses, and you realize that everything was, was working well, but one Ethernet cable was broken, and they don't know how to repair it. So the full thing is down. So yeah, I'm happy to work on that and change that to a more suitable term to refer to that type of autonomy or independence. Yeah, thank you.
All right. So any question from the floor or in the no? Because I think okay. If not, I think to answer the Leandro question, I think yeah, from the rooms and from mailing list as well. I think his draft is quite very fit with Gaia, and yeah, we will collect the comments from Maralis and then from the mailing list as well, and then we will releasing like a call for adoptions in the mailing list, and then waiting for comment for another all the members, and then we will move forward for that. Okay, so then I would thanks to Leandro,
Thanks.
yeah, for it's quite late from your side. Anyhow, so okay, so yeah, thank you, Leandro, and then we keep in touch and then exchanging on the mailing list. Thank you. Okay, so let me move on to the second slot on the talk from John Robert from Philippines. So now let then the I will pass the token to John. Okay.
Hi, hello. Can you hear me? Leandro, I think you have to stop sharing for now. Yeah, so I have sent a request just now. Um,
Okay, you granted.
yes, and now I have to share this. Is the is the slides visible to everyone? Hi, good morning. Welcome to the Gaia Working Group meeting. I'm Bert Mendoza. I'm a senior science research specialist at the UST in the Philippines, and also a PhD candidate at the University of the Philippines, Diliman. And on behalf of of my colleagues, thank you for the working group for having us on the meeting. And today I'd like to share our results and the insights from a research project we did with the support of the European Union and Asia Connect, with the goal of connecting the unconnected. I think, as we know, building community networks requires a collective effort, little, but in our case, we discovered that it actually not the collective effort is actually a village. We implemented this what we call Bayanihan nets, our own flavor of a community network that embodies the Filipino spirit of Bayanihan. So Bayanihan is a term, Filipino term, which refers to unity, cooperation, and responsibility, shared responsibility. Digital Let me start with saying that digital divide remains a pressing problem in our country, and despite many advances in technology, many Filipinos, would you believe, will still lack stable and reliable internet access in their homes, right where they actually live. 18% of them have no internet access in their households, and in their communities where they reside, only 12% have free Wi-Fi service that can be provided uh, to the members. And among the communities that has connectivity, 29% of these actually has fiber facility available. And these figures highlight the urgent need for us to expand connectivity and ensure that the digital infrastructure what we're providing reaches the underserved and unserved communities. One lesson that stands out when we look at the current initiative of the government is that we can characterize it as top down and centralized, and it's a large scale um, approach. However, this kind of approaches, uh, almost always there's a high likelihood probability that it will fail to deliver on its promise because of bureaucracy bureaucratic hurdles, and such as security permits, um, and it becomes slow and tedious. So what's the what? So we thought of an alternative of having this so we thought of other alternatives instead of relying on the central government to do this for us. We thought of de- deploying localized micro approaches. We identified small and medium-sized ISPs and telecom operators that are present in or areas where large operators don't have yet their infrastructure. These ISPs and operators have actually very close relationship with the local government and community, and much of their practices can adapt to their local needs and conditions. They don't have that kind of business model that applies to all of the to all of or a wider customer base. So having targeted this kind of ISPs, we found that there are still gaps and challenges in order to bring them up, to uplift them. Many of these ISPs, or actually cable operators, have lacks in technical capability. They're more adept in traditional cable TV delivery service, um, and once we they have to develop the capability. Once we develop that, we have to teach them the business side on how to be competitive even within their area of operation. So with the project, we developed a framework, that strategy that designed to expand the absorptive capacity of the specific cable TV industry, addressing both local and international and organizational challenges. We engaged the operators, cable TV operators. We pulled in the academe, the RDIs, the local government, and civic groups. That's a very important, and actually the communities, to be contribute to the project. We attempted to adopt modern technologies like software-defined networking, to improve and automate some of the operational tasks of uh, of the the cable operators. We also decided. We also implemented internet exchange points with the hope to localize traffic, reduce costs, and improve performance of the members. We strengthen the skills through training, linkages, and active participation of the communities. We brought this members of this industry, to a wider audience, to wider community groups, to network operation groups, so that they'll have more visibility of what's going on, and they'll have an idea of what the what it is to actually operate an internet service provider. We empower, lastly, and support and emphasize bottom-up approaches, where we tap the members of the communities and these small operators to build the actual infrastructure and maintain their local networks. At the core of the project, you can see here is it's a design. It has three components. We have At the core of the project is the Connect IX, which links local cable operators to the broader domestic internet ecosystem. This infrastructure we established with the hope, with the goal of connecting the cable operators to existing neutral internet exchange points already available. We have PHOpenIX in ASTI that already connects most of the ISPs in the country, and so having that kind of point of presence, we pushed, we established a, a, a an equipment closer to them. We also have CIMIX, which is a test bed infrastructure, if you will, internet exchange, internet test bed infrastructure, which we located in the north of Manila, way north, about probably 6 hours away. It's actually and This serves as a test bed where we experiment new technologies and validate solutions before we deploy it widely in the Connect IX. And finally, we follow the Bayanihan Nets principle to provide the framework and community model for building the community network. The goal is to embed cooperation and the spirit of Bayanihan in the design, ensuring that we are putting in community-driven resilience in the forefront of, and also um, uh, in mind. The Science City of Muñoz Internet Exchange. The city is called Muñoz, by the way. It's in the province of Nueva Ecija. It was designed to develop and evaluate SDN applications for interdomain routing. It's home to several research institutions, making it ideal for site for experimentation. We built a purely software-defined internet exchange, and at least during that time, we were able to connect at least 3 RDIs in the area, along and interconnecting them with the local cable TV operator in the area, cable TV operator operating in the area. This particular infrastructure also links directly to PHOPNIX in Manila. Again, it provides access to all the internet routes already available there. And with this integration, we are able to install, at least test SDN principles with interdomain routing without actually affecting the greater or the production internet exchange already operating. Connect IX is the open neutral software-defined IXPs for cable operators, and we co-located it in the head end office of one of the cable operators. It connects again one cable operator and distribute routes from the PHOPNIX. It means that all the participants of Connect IX would have access also to the routes from PHOPNIX. The one thing that is different from this internet exchange is that not only do we this Connect IX links cable TV operators, but also community networks. This we as participants of the IX. So this particular integrations allows communities to have direct access to the internet service providers, and hopefully they can negotiate with them, obtaining bulk prices for internet service, and also have a multiple available. They can have they multiple ISPs will be available to them. We extended the IXP in order to connect the community to the IXPs, to the community networks, to the ISPs. We actually we extended the connectivity with the 26-kilometer fiber optic cable from the head end to down to the community to the neighborhoods. The deployment was funded through Asia Connect, and it was installed with the oversight of Connect. The fiber was mounted using pole attachments or facilities owned by the local power company. And this put proof and as we know, in an economy like the Philippines, this is one of the biggest challenges. Pole attachment fees and for the process for applying one is low, tedious, and often uncertain, because it's actually most of the poles are owned by a private entity. And this underscores the need for government to actually promote open, neutral telecom infrastructures to make this kind of projects, community networks, more efficient. And at the same time, we learned that for those areas that not so these areas that we served or we established the community networks in are, I would say, low income neighborhoods with in an area that's highly densely populated, and mostly we figure, and what we learned is that these communities can actually provide or use their own facilities. They can put up erect poles if necessary, and that's one of the things that uh, something that was very insightful for us. And the 28-kilometer fiber only was the backbone, was the upstream, and within the community, as I mentioned, it was highly dense. It doesn't have proper roads within these neighborhoods, and so we thought we had volunteers within the community, members of the community installed an 8-kilometer fiber optic backbone along a rural coastline, serving a population of about 10,000. This effort was completely community driven, with the project only providing them with the training and also the supplies and also the equipment for them to do to supply to build their own municipal fiber. We call it barangay. So the smallest government unit in the Philippines, a barangay fiber network. Um, it with that backbone, we were able to provide public Wi-Fi to um, various public spaces within the community. For example, the government buildings, small government buildings, the schools within them, health units, and also recreational spaces. Um, Others hosted some of the Wi-Fi access points actually were hosted by residents. And with this infrastructure, we were able to uh, deploy the first off-campus community-based eDROM enabled network in the country. This is the first one. It served as a model for nationwide student and teacher mobility across schools and communities, which enabled flexible anytime and anywhere learning. And after 1 year of operation, we gathered statistics and we found that almost 3,300 unique users or devices were actually connecting per day, and we saw more than 8,900 unique users in 1 year. That's close enough with the 10,000 population. For the and one thing to note here is that it's funny because these communities actually have members that have linemen that have members who are actually linemen for telecommunication providers. So these people, these persons uh, who volunteered, contributed in helping out and teaching other members of the community in and using the fiber equipment, and also doing the fiber splicing themselves. For visibility and sustainability, talked to the we've we work closely with the communities and the social civic organizations, um, um, and also the municipal government for future funding and expansion. Right now, we have target the Rotary International, which actually supported this activity, uh, is giving out grants for projects, and we're looking at that at that kind of funding to support and also continue this effort. Uh, looking to conclude and to look ahead, no, internet exchanges can bring ISPs, community networks, and national internet infrastructure together in one ecosystem. This integration ensures that we are collaborating on all levels. The communities with the right training and support, we believe and demonstrated that they can build their own fiber and doesn't need to rely on. At first, they have to, but uh, with consistent training, they should be able to build and maintain their own backbone networks. Community-based public Wi-Fi services strengthens digital inclusion, and especially with eDROAM, soon it would open up possibilities of providing or delivering internet service to actually those users who need it the most. Local governments, civic partnerships, and municipal support, as we know, is very important in order for community networks to succeed. That actually concludes my presentation. Maraming salamat po. I hope that the insights here have given everyone a clear picture and sparked some ideas in the working group that we can explore further. Here's the document, the website where we published an article on the university website about our experience and some additional photos. Um, if you want to check that out. And now I'd like to open the floor for questions, and um, can ask anything about anything I covered, and any areas that you want me to expand on. Thank you very much.
Thank you, John. So we have the question from Jane. Let me.
Jane.
Yeah, John, I have a question for you about the polls. When they were putting their own polls up in the community,
Yes.
are you able to charge other people to do infrastructure sharing arrangements so you can bring in revenue? I was just curious.
No, we haven't done that. It
Okay.
was just out of, it was really ad hoc. We were expecting, so when we started the project, we were expecting there were already all infrastructures in the area, but upon when we were already delivering and also configuring and setting it up, um, the you I have to say the houses are very dense. The area is very dense with houses, and so traditional pole infrastructure won't really cut it, if you so to speak. It won't be standard. So most of the time, this the members of the community, these households, residents, put up their own small, very thin, um, what do you call this, galvanized steel pipes for their own use. And then that's where we lay down, or that's where we hang the fiber optic for them. But we haven't actually thought of using it to charge, or using it to charge anybody, aside from the community, for the use of it.
Okay, I was just curious because it could be such a complicated thing if you have to pay the poll rates because
It
it
is.
can be a lot. Yeah,
It is.
it's a
That's one
lot.
of
It can
the.
really delay a project. But thank you so much. This is very interesting, and I'll be quick because I know there's somebody else in the queue. But thank you for answering that question.
Thank you, Jane. I might have to stop sharing so that.
Um,
Okay.
Thanks
Thanks.
for the very
Hi.
hi. Thanks for the interesting presentation.
Thank you.
I'm curious. So you mentioned that almost all of the community is using the network. Uh, is the use mostly to read stuff on the internet, or are people also putting up their own content, or, for example, running things like Nextcloud to share
Uh,
um, local data without uh, going outside of the region?
that's good. It's a good question. Thank you, Benson. Um, these Most of the users are using it for access, internet access only. I have to say, with the level of maturity, they don't have. We haven't set up that kind of infrastructure yet within the community network. So um, the service only, the kind of service we only provided was access to the internet. And there's a funny story, actually, and I can tell everyone about it. Is that once after we were able to deploy the public Wi-Fi services in various places within the community, there was a time that the community leader was asking us to shut it off during midnight, during nighttime, because they saw a lot of people crowding these places, and most of them were kids actually playing video games on their cell phones, uh, connected to the internet. We saw that as actually an opportunity, because at least the community has now visibility on the kids, what they're doing. It's no longer in the dark. And so it was just a funny circumstance that we encountered. But to answer the short question, we haven't reached that maturity yet, providing internal services for the clients. And that's it. Thank you.
Thank you.
Hi, John. I also have a question. So, do you have any kind of stat or demographics about how many users that currently using your services on the Community network?
Um, that's part of the um, activity we want to do for when we get continued funding. To be honest, this project has stalled in the recent years because of this part of Manila, this part of Philippines is frequently affected by typhoon. And so the fiber network that we laid down there, even if we fix it, maintained it, at some point, uh, and it's going there is 2 hours drive, and the roads within the community is not really suitable for cars. It's really meant for small vehicles. It was a challenge to get there and to maintain it. And so we didn't have the statistics already went down. We lost the statistics, and that's one thing of one of the services we'd like to put up again or to restore once we get additional funding. But we have the statistics, but for the continued use, we it went down.
Okay, thank you. Then. I think we don't have
Thank you.
people in the queues, and then we quite running out of time. So if we, yeah, anyhow, so it's quite really nice work. So if we still, there, all the members have their questions, so we can exchange in a mailing list then. Okay, then I move on to the third slot. That's gonna be Polly. So now I pass the token to you, Polly.
All right, thank you. And let me share my screen. All right, good. All right, so I'm actually from academia. And so this is something that's coming out of a series of projects that I'm running. So I'm going to talk about Twitch CDN. So Twitch is an internet video service. I don't know if you guys are aware of, but you know what? It's okay. Let me introduce it this way. So the internet video services can be divided into 3 classes. The first one is called the store video, such as Netflix, YouTube. We watch video shows over the internet. So the delay and bandwidth requirements for this type of content is relatively low, but the number of viewers watching a video can be simultaneously can be high. The second kind is conversational video, such as what we're doing over Data Tracker now. So the videos or my voice is going to your places live. So you can imagine the delay and bandwidth requirements being high. But more often, there are just a few of us, so the viewership is low. And Twitch belongs to the third kind. It's called live video. Okay, it's very much like the YouTube live video if you have experience with that. Okay, and the video being transmitted, audio being transmitted are live. Therefore, you can imagine the bandwidth and delay requirement being high. And what's unusual in this type of video service is that the viewership can be huge as well. And let me give you an example. Okay, so Twitch is a live video service serving mainly the game streams, okay, esport events. Back in 2018, if I use a physical sports event to compare, Super Bowl is one of these major American football events, as you can see from the picture here. It's super hot, okay, very popular event. And the TV commercial time is the most expensive, okay, for this event. And now look at this one, League of Legends. Okay, this is an esports event. This is the World Championship final. Okay, in places where gaming is very popular, you can see that people gather physically to watch people playing on the computer. Okay, so they're gaming. And guess what? Okay, this event is also broadcasted, and it draws 99.6 million viewers, even higher than the viewership of a Super Bowl. And this event, guys, is only on Twitch. Okay, So obviously, Twitch serving the videos using Twitch's own CDN is very successful, sustaining such a high viewership with high delay bandwidth requirement. Okay. But at the time, there's very little report about Twitch's CDN. The size, the expand, the geographical distribution, little is known. Having working with students, sometimes undergrad students, I was brought to attention to the existence of this service and realizing the size of its reach, and therefore we started this series of work. And the earlier ones are more just to understand how Twitch's CDN work, how a user actually eventually get the video, where the CDN servers are, the interaction between the client and the server. And the later one are more to explore broadly, okay, the geographical span. So this one focus more on Europe because we do see that the Euro distribution is dense. Okay, and the sizes are high. And finally, earlier last year, the end of last year, we did a complete global scan of Twitch's CDN. And the report today focuses more on what the findings from the global scan. So let me give you the results from earlier work. So this is essentially trying to backward engineer and discover exactly how Twitch delivered the video. And then we start by talking about the architecture. So it's a network of server clusters. So there are these server clusters around. And within each cluster, there are a number of servers. So for example, A3 is a server in cluster A. And in each region around the world, okay, the chance is very high that you see multiple clusters. Okay, so this is a very sort of a coarse granularity of the Twitch's CDN. And when a viewer comes along, it will send a request to a special server called Usher. So this Usher is someone, okay, deciding which cluster the client should go on and fetch the real real video. So first, which cluster and exactly which server in the cluster to fetch the video. So given the information, the client would then be able to download the video from the particular server. Okay. Before I go on to talk about exactly how we take the global scan of Twitch's CDN, I want to focus more on this, how the Usher decides which cluster and which server to assign to a viewer. So we actually collected the data and analyzed data at the earlier half of the project. So we see that the location of the cluster are very often close to the client. Okay, so there's certain co-locality. It's not strict, it's not always the closest, but it seems that there's a loose co-locality. But the selection of the server within a cluster, it's then very random. Okay, now given this, if you want to discover all the CDNs sitting in NTU, Taiwan, all you see are just servers in Asia. So to enable to do a global scan, what we do is this. So the measurement methodology. To subscribe to a VPN service that will allow us access to machines all around the world. Okay, so the crawler is actually set up in the lab, but we connect to VPN servers around the globe, particularly 686 of these. And this is the geographical span. And you will see the quantity of VPN servers we have access to. And so we call these vantage points. So from these, we then can discover the servers. So the essentially how we crawl or discover the service is just repeatedly requesting the videos. Okay, there's an API we can actually ask from Usher and discover the list of all the video channels there are, and we simply ask for the videos, and judging from the servers we get the videos from, then we discover the individual servers. So that's the idea. And we do this repeatedly from all the VPN nodes, through all the VPN nodes we have access to. And here's the map of Twitch's CDN. So you can see that, okay, it's very concentrated in Europe. Oh, by the way, each circle represents a cluster, and the size of the circle represents the number of servers, okay, in the cluster. Okay, and that's reflected here in the statistics. Almost half of the servers are in Europe. Okay, second highest is North America. Asia is actually catching up, and then there's also a sizable, number of sizable sort of Twitch users. So 216 servers, and then at the bottom, the Oceania. But total, we have discovered about 2,000 servers, okay, across 64 clusters, okay, and the majorities are in Europe and North America. So what we did here is we did a crawl. Okay, how do we know the methodology is going to give us the right information? Okay, are we missing something? So here's our analysis. Okay, so I ask all my students, are you sure? Okay, because especially after seeing these entries. And before we look into these entries specifically, let me explain the tables I'm showing. So on the left is the Asia CDN clusters. Okay, so this is the first column is country, second column city, third the name of the clusters. So you can see a mapping between the city and the abbreviation of the city, BKK, and cluster 1, cluster 2. Okay. The fourth column is the number of servers we discover from IP info. So this is a registry, okay, that sort of openly share information about a particular AS autonomous system. So we actually ask IP info or look around in IP info and discover all Twitch's IP address. And we do reverse DNS lookup. So from individual IP addresses, we discover the host name. And from the host name, we are actually able to see key phrases like this, BKK01, BKK02, okay, that indicates the location of that particular machine. Okay. So in a way, what we are trying to show here is from IP info. Okay, we see there should be 32 servers in BKK01, but from our data, we see no active servers. Okay, so we repeatedly request for videos, but we just never see servers with this host name, okay, in it. So similarly, this is not the only one. In Jakarta, we see a subnet, a cluster that has also no active server. Philippines and Korea, to our surprise, there are 3 clusters, and there's one cluster. There used to be a lot of IP addresses assigned to it, but we see no active servers. Okay. Now, with all these entries around, we try to change the parameter settings of our global scan. So we try to do this. In the scan we did, you saw earlier, we use just one VPN server per VPN subnet. Okay. And we changed to just scan from all the VPN servers there are. Okay. But no worry, we only do this for these particular regions. Okay. And we scan only for top 2,000 channels. Okay. In this experiment. But to validate, we now scan 20,000 channels. And again, for only these particular countries. And you know what? We find no differences. Okay, those particular clusters remain having no service. And so we try to do another matching because back in 2023, we have a full scan of the Europe, okay, CDNs. And so 1 year later, most of the clusters, okay, are there. Okay, but we do see some migrations, for example, in Germany. Okay, so some server seems to be moving from Berlin to Frankfurt. Okay, and there are some decreased clusters having a decreased number of servers and some increased number of servers. Okay, so here we see overall, right, there are servers moving from regions, from cluster to cluster within a country, and maybe some servers moving from one cluster to another cluster across different countries. Okay. But then this is the last slide. Okay, why do we see these null clusters? Okay, after searching a little bit, Korea, there are no servers because February 24, there's a hike in accessing the internet in Korea. The internet access fee takes a major hike, and Twitch decided to close the Twitch servers entirely in Korea. Okay, and so that is because of changing operation costs. But until now, we don't know exactly why. The servers in Thailand and Philippines, it appears that they used to be there, but are no longer active. Okay, so that is actually my report here. Okay, so if there are questions, I'd be happy to take.
Yes, I'm right.
Okay. Thank you for this very nice presentation. Very interesting topic, and I've read your previous papers. So thanks for doing this work. Maybe one suggestion on the use of VPN. There have been some previous work mentioning that some VPN lie about their locations. So it might be good to actually cross-check whether the servers are geolocated where they are actually meant to be. And my second point would be, do you also look at whether users, when they are accessing the Twitch content, are they actually crossing an exchange point, or basically have you been running trace route between the vantage point and the Twitch server to understand the interconnection between the users or the VPN servers ISP to the Twitch network?
Oh, interesting. No, we did not look deep into where the VPN clusters are and how they might relate to the use of the Twitch CDN servers. That's actually a good suggestion. One of the to-dos we have is, so currently we subscribe to one of the global VPN services. I think it's NordVPN, if I recall correctly. Another way to validate your concern is to try to find vantage points using other VPN services. Then maybe we might discover Thai and Filipino servers,
Yes.
perhaps.
Great. I would love to continue this conversation with you. I will reach out.
Okay, great.
Okay, next,
All right.
Jonathan.
Thanks.
Oh, it's Polly disappeared. I was going to ask her a question. There she is.
Polly came back.
I just wanted to know if you've considered using the RIPE Atlas platform for doing any of your measurements.
Could you repeat that question?
Have you considered using the RIPE Atlas platform for doing any of your probes?
I have not. I was not aware of RIPE Atlas.
Okay, so RIPE Atlas has millions of network probes around the world, including many, many on local ISPs in markets like the Philippines and Korea and, Thailand. And you can at least use them to do DNS lookups, pings, trace routes, and HTTP queries to see if the servers are existing or what their trace routes or AS paths to the nearest Twitch resources are. So you might find that very useful.
I already find it useful. If it can send HTTPS, that should serve our purpose because all the queries and responses are in HTTPS in Twitch.
Yeah. All right.
All right.
Good luck. Nice
Thank you.
presentation.
Thank you.
Okay, John Mendoza.
Yeah. Hi, Polly. Bert here.
Hi.
Hi, good to see you. I was just
Oh,
wondering. Yeah, I was wondering. Have you ever considered using virtual machines in cloud services as well as your vantage points, as opposed to, or or basically setting up your own VPN infrastructure? And what were did you find anything about it you could share with us?
good question. So in one of the works, I think it's in the 2022 paper, we try Azure. We try Azure, so it's a commercial service. But it did not work as well as we'd hoped for. I think the problem is probably related to what the Amresh was trying to suggest that even though in VPN services they claim that this server is at a specific location, but it's not quite. But we find it the issue is more serious using Azure. We try to set up virtual machines locally, but we can actually sort of create multiple crawlers. But crawling from within NTU, we discover only sort of machines from within this region. So I guess the point is to try to be able to crawl from the vantage points.
Mm-hmm.
And so that's why we went to Azure. It's a virtual machine
Yeah.
style.
Yeah.
And so we try to compare that. It's costly, and yet they are even more fuzzier about their location because I guess these cloud platforms, where it is probably not that important to their users. But for VPN, it's a little bit more crucial, but they can sometimes mislabel, as Rash was trying to point out. Yeah,
Right. Thanks, Polly.
no problem.
Okay, thanks, Polly. Very nice talk and a very nice discussion here. So I think since of the time is quite very tight here, so just gonna move forward to John, our fourth speaker then. So
All
Polly,
right,
can
thank you.
you
Sure.
yeah, and then can you stop sharing and then we can pass the token to John.
I just heard in a side channel that there could be some consolidation of Twitch infrastructure onto Amazon platforms. So that may be a reason that it's disappeared. The clusters have disappeared from some places. Now I'm trying to find a way to share, and it doesn't look like the button's available to me yet. There we go. Adesorn, you see my share request? Yeah,
Yes.
there we go. See if I can find the right thing. Okay. So this talk is on the local networks demand, supply, and financial planning app, which we really just call LoCnet app for the moment. And it's an online tool built by my company and SKC Economics in Australia. and supported by a very large number of organizations, including Association for Progressive Computing, ISOC, APNIC Foundation, Hello World, and WACC. And I've probably missed some that have been aggregated up through APC. Introduction to me, I've been active in ISP networks now for 31 years. I am a native of Kansas, but I've been living and working in New Zealand and Asia Pacific since 2003. In my day job, I'm a radio engineer, in addition to doing software development and data analysis, writing some research papers, doing some training, and being active in internet governance. So I do a few things. And I'll just get right into the application. And I'll tell you, this tool is for organizations who are going to build a community network, who need to know if it's going to be financially sustainable. So, I mean, in some cases, this could be for small communities. In most cases, the appropriate user is going to be the funder, someone thinking to put grant funding into a community network or a group of community networks to see if applying funding is going to result in a sustainable business. So it's an economic and financial model to evaluate the demand for broadband at a particular price and the financial sustainability of community networks in underserviced communities. And so really this model is made for communities that don't already have broadband, or their only options, maybe Starlink, are so much more expensive than the community can afford that they wouldn't be considered by 99% of the people living there. As inputs, the tool takes characteristics of the community and a network configuration. And as outputs, we end up with a network configuration, a demand and community benefit analysis, and some financial documents, a profit and loss statement, and an investment and operating cash flow statement that can be downloaded as Excel and used for analysis. So on the supply side, we do a very basic coverage model. This isn't taking terrain into account yet, but it does take into account the radio frequencies in use and the technologies in use, and assumes either fixed wireless or mobile broadband, depending upon how you've configured the model. It has a peak hour utilization model to determine for however much broadband people are expected to use in a year, say starting at 10 or 15 gigabytes a month this year and growing by 20 or 30% per year for 5 or 10 years. How much traffic is each user going to be taking in kilobits per second during the peak hour of the day, which is usually 8 to 10 p.m. In some markets, it occurs at different times of the day. So based on that peak hour utilization, we also create a backhaul model that determines the requirement for and the cost of backhaul. And that cost, of course, increases if you have an expectation of traffic growth throughout the term of the network. And I mean, everybody does. And finally, it calculates how much electricity, how much power is needed, and what it will cost to provide those power systems, depending upon where in the world you are. On the demand side, there is a demand curve that is based on academic research and household surveys that says, right, if if broadband is going to be costing 10% of household income, you're really only going to get a few percent of your community subscribing to it. And as you get closer to 2% of household income, you get greater and greater uptake, trending towards 95% uptake when your broadband is 2% of the local household income, not necessarily the country's median household income, but the local household income. There are some calculations in there depending on user groups. You may have a higher device ownership in households that are above the median income than you do in households below the median income. And there are also provisions for public access facilities, public Wi-Fi, as John Robert was talking about, or internet cafes and these are adjustable in terms of how many hours you expect people to use, how many terminals are available, and how congested you expect these public facilities to be. So in terms of economic impact, the model does provide community benefit analysis. And I guess the difference between giving someone a Starlink terminal and helping someone build a community network is when you give them a Starlink terminal, the revenue from that, it leaves the community. It goes to Elon Musk. It leaves the country completely. It doesn't have any impact on anybody in the community. When you have a community network, the money gets paid to the local ISP. And yes, they have some backhaul costs, but also they have costs for paying people to do maintenance on the infrastructure of that community network. So there's a benefit to the community because you're employing people in that community to provide the broadband. The investment and cash flow statement can show if you've made reasonable assumptions about what you're spending on the network and what you are likely to get as uptake. And it basically says you're going to reach your maximum penetration based on the cost of the product and the wealth of the community on a straight line 3-year ramp up. So after 3 years, you'll have sort of the maximum uptake depending upon what it costs you to provide the broadband. And then it shows you your profit and loss statement. And hopefully that takes us through all the basics. And there, yeah, so I'll show you the app as just some slides here. And I put stars next to the most important things, but you need to define how large your community is. And most importantly, the total number of households in that community and what their weekly household income is. I have data populating the tool for hundreds of economies. But when you get down to very small island economies, often the data is poor. And in that case, you might see under weekly household income that the figure is red. The whole box is red and it just has 100. And that means, oh, we've just had to make a guess because we don't have good data and you're really going to need to tune that yourself. The market that I'm working in now is weekly household income of around $70 US. So it's quite hard to provide mobile broadband service given the expense of the equipment. You have some different technologies, frequencies to define here. So are you going to build a fixed wireless network? Are you going to build a mobile network, GPON, fiber to the home network, or a public access facility, or some combination of these? And if you're going to build any sort of wireless network, well, what frequencies do you have access to? We make the assumption that you're going to have 2.4 and 5.8 gigahertz because they're nearly universally available. But when it comes to other frequencies for use with LTE, definitely not universally available. So pick what you have. Manually define your terrain and vegetation. And there are little question marks next to all of these menus that you can click on to get better explanations of what's going on and what this variable means. And I guess now's the time to mention the interface is multilingual. We only have Spanish and English right now, but the way the application is designed, it's trivial once we have a translation table to add different extra languages. We hope to do that soon. The expert configuration has a few things that need to be done. You need to verify your cost of labor in the local market because you're building a community network and your people can't work for free. So put the labor cost in, and then you have to decide, well, when I'm building this network, am I starting out with a CapEx subsidy? Is somebody giving me a grant to help build this network? Or is somebody going to lend me money to build this network? Or is there going to be some combination of the two things? Because when you build a network, you need to buy the equipment and install it first, and that costs money. So the CapEx subsidy is a US dollar amount. And then you have down at the bottom proportion of capital funded by debt. So if you expect your network to cost $20,000, you have a grant for $10,000 and somebody's giving you a loan for $10,000, then you say 50% of your capital is funded by debt. And this is important for the financial calculations. And you might think, oh, this is too complicated for a community network. But the idea here is to create a sustainable community network. And the problem with most community networks I've been involved with over the last 20 years is that they've been financially unsustainable. So we hope to help that with this tool. The expert configuration is very long, but other key variables here are how much traffic are you expecting in your first year of operation, and how much do you expect that to grow? 5 years ago, this might have been 1 gigabyte per month. Right now, I would say the minimum is 10 gigabytes of traffic per person per month, but you may want to start at 15 or 20. If you're in South Asia right now, everybody's using more than 15 gigabytes a month of data. And then household size, especially if you're building a fiber network or a fixed wireless network where you're delivering connectivity to a household and people within it are using Wi-Fi on a single terminal. Very important to know how big is the household size. If you are going to power your network with mains power, it's important that you have the installation cost here and how much the power costs per kilowatt hour, because this varies immensely from place to place, and small islands tend to have very high cost per kilowatt hour. And some South Asian countries tend to have very high mains power installation costs. If you have mains power available already at your locations that you're going to build, set it to 0 because this is a capital cost. And yeah, the last one. So that's done with the expert configuration. There's some variables in here. If you're building a solar system, put your costs in for how much it costs you for solar panels and batteries and so on. Or if you're not, or you just want to leave these suggested variables, just leave them. Now that's setting up the community and your expenses, and now you have to build a network. So your little drop down here in the network builder section has a list of technologies that are available depending upon what options you chose earlier. So if you said, I'm going to build a GPON network, there'll be a GPON network in there for you to choose. If you said, I have access to 3.5 gigahertz spectrum, 3.5 gigahertz spectrum will be here as an option for you to use. So pick your network, pick your power system, the type of tower you have and how much you expect that to cost. If it costs nothing because it already exists, set it to nothing. And then you need to decide, are you having 2 towers or 1 tower? If you have 2 towers or 3 towers, you need to connect them together with a network link. Network link is just really a CapEx charge. And then a backhaul link gets your network out to the internet. And a backhaul link has your CapEx charge plus your OpEx charge. So it's important to see, to set your fixed monthly charge and then your cost of traffic per megabit per second if you're buying wholesale backhaul. And if it happens, your cost of traffic is nothing, then set it to nothing and you only have a fixed monthly fee. Say if you're on unconnected.org, you just set your $60 a month and that's that. So when you run the model, you get a summary of outcomes. The important things for someone trying to build a sustainable network are going to be EBIT, EBITDA, what your adoption rate is of the network, what percentage of your community you've covered. In this model, I covered 55% of the users with the network I built, 95% adoption, and a $2.91 per month ARPU. The demand community benefit analysis table sort of shows you where the demand is and what sort of benefit you're getting from corporate users, business users, service providers like schools, and households in the above and below median income range. Profit and loss statement, investment and cash flow statement, and then just a bill of materials for the network elements. So my time is over. I don't know if I've lost my ability to speak, but I have two or three more slides left. The primary levers here, what influences the model the most? Your household income. and if you've selected the appropriate technology. If you've said, I want to build a 700 megahertz mobile broadband network for a community of 50 households um, in a low income area, you're going to find financially sustainable. No, not at all. You've spent too much money building the network. You need to use affordable technologies for this community. So cost of backhaul is very, very much a primary lever for the network. If your backhaul is too expensive for your community, it doesn't matter if your network is very cheap, your OpEx is too high, people won't be able to afford to use it. And then finally, what you've done for CapEx subsidy or cost of borrowing. In the future, we'd like to do some authentication and login. We're very close to being able to save and load projects. We are close to having charts for some of the tables that we've shown you. I would like to have more granular control over the equipment costs. And of course, I'd like to move from a theoretical coverage model to one that is location specific. So you can just stick a pin in the map and we'll give you a location specific radio coverage model. And of course, additional user interface languages. For some links here, this deck is online for you to download, so you can get the links out of that. There is a working version of the model, a test version, there's quick start guide, full model documentation, and some links to the organizations involved in building and funding it. Finally, we have a code repository, and we will very soon make this open source and start looking for collaborators to help us with some of these features. And I'm over time, so thank you, and I'll take any questions if there are some. And I'll stop sharing too.
Hi, John. I have a question.
Sure.
So previously, I think I saw some kind of document from ISOC, so I mentioned about a kind of a tools or kind of handbook to building the community network, but that one is what mostly focused on the technical part. But now you mentioned about the uh, application for financial part. You have any plan to, yeah, publish this one or escalate this one to be kind of standardization or some kind of a cookbook for the community?
I think between APC and ISOC, both are interested in seeing some more resources published on this. So yes, things are happening slowly, but yes, things are happening.
Yeah, if you're interested, I think Gaia could be a good venue for the standardization, submit the draft, and so on.
Okay.
Yeah, thank you. So we have a quick question, John Mendoza, Robert.
Yeah, it's Bert from Ask Steve. John.
Hello.
Yeah, can you hear me? Yeah. I was
Yeah.
just wondering, how often do you normally use the tool? Only at the start when you build the network, or what do you advise on how frequent do you go back to the drawing board, so to speak?
This is an initial planning tool. So it is really just for setting up the initial parameters. And then when you want to evaluate how you've done, then you plug your own numbers in to see, well, what was my actual cash flow? How close did it come to the model? How am I diverging from what I'm expecting to pay in capex, in opex, in repairs and maintenance, and am I getting the revenue that I should be expecting? So it is really just do this for the initial conditions, and then use it to compare on your own later.
Thanks. Would just a thought. Would it be useful for having a tool as well for for maintaining and also keeping track of the financial? I know it's part of the business, but for starting, for those starting out like community network, and for those who are not yet well adept yet with business, might be a good tool for them to have a more of a template they can use
Mm.
for to maintain their networks.
I'll thank you. I'll take that on board, and I will discuss that in my next meeting with APC.
Thank you, John. Good to see
You're
you.
welcome.
Okay, all right, thank you, John. I think we are quite running out of time now, so I just pass the token to Amoresh, and then Amoresh, we might just squeezing your time just a little bit, just to
The luck of the last one, really.
yeah, if you can speed it up, it would be good.
Sure. I've requested to share my screen.
Yeah, I got you. I just granted.
Okay. Oops. Just a minute. I'll do it once again. There you go. All right. Hello, everybody. So my name is Amrish Fakir. I work as an internet measurement and data expert at the Internet Society. And I'm also co-leading the Internet Measurement Project, which is focusing a lot on internet resilience. And this is what we are going to talk about today. Basically, the intersection of internet resilience and power grid resilience, because we know they both need each other to function, and we need resilience on both sides eventually, because things are so interconnected those days. So this is work that has been done by Tanya Schiller, Kevin Vermeulen, Italo Cunha, and Fernando Quibers under the Internet Society Pulse Fellowship Program last year. So you might recall around almost a year ago now in Spain, there was a widespread power outage, which lasted, I think, for more than 10 hours. The whole country was brought down, and also neighboring countries. They had issues in Portugal, some in France, and the problem also cascaded in Morocco, which is not connected to Spain as such. But the fact that all internet services were also brought down, Morocco, which actually heavily depend on Spain for interconnectivity, because a lot of cables from Morocco land in Spain. Even internet access was disrupted in countries like Morocco. So first, let's try to understand how power transmission happens. We have on one side the generation of electricity coming from either wind turbines or oil plants or hydro plants. So there is a stepping up substation where power is stepped up so that it can be transmitted over long distances. Sorry. And then before it reaches the consumers, it is stepped down for people to be able to have low voltage electricity at their home or in their offices. So we know those transmission lines and this system of transmitting power has been there for a very, very long time. And we know how resilient and robust they are. But we also know that they can be sometimes impacted by different types of outages. So what can go wrong those days with the transmission of electricity? A lot of things can go wrong. For example, if there is a spike in the demand, so there can be an outage that happens. you have also the case of weather conditions. So if you have extreme heat or very cold weather, this can have an impact on the power lines. Equipment failures, of course, if there's a lack of maintenance, equipment can fail. Obviously, human errors because of misconfiguration. This doesn't only happen on the internet, but can also happen on the power grid as well. And as I was mentioning, there is more and more interconnection between networks and the power grid, because a lot of power transmission systems are online and are also managed centrally. So if there can be cybersecurity or malicious attacks on SCADA or have grid intrusion, which can create outages. And this is happening, and we know cyber attacks on power is something true, and a lot of countries or institutions are actually trying to enact regulations, but also policies to make sure that those critical infrastructures are also protected against cyber attacks. So this is not something which is hypothetical anymore, and a lot of effort is being put into making sure power grid is actually resilient to different types of attacks, namely cyber attacks. So going back to what happened in Spain, there was some cascading effect, some surge in demand, and some stations started falling, and it created some sort of chain effect, and a lot of substations went down, and power eventually went down. And obviously, because the internet relies heavily on the power grid, we have seen a decrease in traffic, actually quite a drastic decrease in traffic, both in Portugal and other neighboring countries. So we wanted to understand what is the interconnection and how closely bonded internet systems are with the power grid. So as you know, the internet is made of many networks which are distributed globally, and those networks, they rely on physical equipment and facilities that are directly connected to power grid stations. And an impact on the power grid within a specific area can have some impact on those physical equipment and facilities within a certain region. And this is what we wanted to measure. So our key research question in this study was how much of our internet operation is susceptible to failures in the distribution network. So first, we investigated the dependency of critical internet infrastructures on local power stations. And in this work, we mostly focus on IXPs. As we know, for example, in Europe, IXPs is quite present, and a lot of traffic is exchanged over IXPs. And we also want to characterize the backup internet path in case of failures. What if an IXP is shut down because of a power failure? Would the ISPs and the members of the IXPs be able to reroute traffic around failure, and also uncover the impact of those failures on local ISPs? So our approach was to first did some mapping. So we look into where are the critical internet infrastructures located, and are they far or close to power stations? So we use OpenStreetMap for the dependency mapping. Then we use a testbed called peering. So it is a global testbed that allows you to run experiments. So basically peering and interconnection experiments. So we tried to simulate a failure. For example, if we had a connections to two different IXPs, if one fails, what happens? How is traffic redirected? And the phase 3 of this project will be really trying to study city level impact due to power failure. In this talk, I will only talk about phase 1, and phase 2 and phase 3 are still ongoing, and we hope to be able to present some results in the future. So obviously, the challenge is that we need data for that, and we do not have data for everywhere. So we have been able. So internet facility data is publicly available on PeeringDB. So it is as good as it is because it is a crowdsourced database. So people go in there, register their facility, whether it is the data center or an IXP, and then put also some geolocation information. And on the other side, we have power station location that are also provided by usually power operators in different countries, but it is not standardized. Some of them would publish this information, some of them would not. And if they publish it, it's usually in different types of format. So our methodology was rather simple. We take the data set. So in that case, we managed to get data set from Tenet, which is in the Netherlands. So this was our first case study. And our plan is actually to run these different case studies on different countries which are providing this information. But in this first phase, we focus on two countries, Germany and the Netherlands, also Austria, because of the availability of data. And they provided data on OpenStreetMap, and it was very detailed geospatial data. The only issue is that it was extremely noisy in terms of the different components that they are publishing in this data set, and we had to do some filtering to trim down to the level of information that we are requiring. There's also another data set from what we call transmission system operators, TSOs. And again, it is the availability of this data is also very patchy. So there is a big concern about providing data in an open and standard format. And I think this is something perhaps we will have to be thinking about, how we can work with power grid providers or transmission system providers to standardize the way they are presenting the information. So one case study that we did is the Netherlands. We got data from Tenet, and then we overlaid that with PeeringDB data on all the facilities that are existing in the Netherlands. And basically what we were trying to do is no, sorry. This one is only about the substations. So we got data from OpenStreetMap on the power stations, and we also got information from the transmission service operators. And what we did, first of all, we tried to match whether those two different data sets, they are actually matching. So we found around 76% of match between those two data sets, which contains slightly different source of information. Once we did that, we then did the mapping with the PeeringDB, which contains information about data centers and IXP networks, etc. And what we were trying to do is to do some sort of closeness correlation. How far is your data center or your facility from a substation? And we were able to map in three categories. So low, which means that it is less than 3 kilometers away. And medium, it means that it is between 3 to 5 kilometers away. And high, which is more than 5 kilometers away. And our hypothesis was that the further away you are from a power station, the more risk you have in having an outage, because there might be many issues that happens between your facility and the power station. So we did categorize a few of the what we call big internet exchange point in the Netherlands, falling into category of being risky. And therefore we could see that some of them are actually quite close, but some others are not that close and could represent a risk. Obviously, those parameters can be tuned so that we have a more realistic picture of the reality. Our next phase was to do a cascaded failure analysis. So our idea was actually to understand closeness relation, and for this we use what we call a K-resilient bipartite graph, where basically we said that a substation needs to be connected to at least 3 single substations. So if one substation fail, it is still connected to other substation. And to run the failure scenarios, because this was all simulation based, to run the failure scenarios, we use 3 techniques. One is based on degree, the other one on bit inverse centrality, and the other one was random failures. And one thing so what we noticed is that if there is no substation failure, of course no outage. But once you cross, for example, 10% failure, then you could see, for example, in Amsterdam, a lot, because of the concentration in Amsterdam, you could see a lot of facilities being knocked out. And if you increase it to 20% of substation failure, you could see that this is now expanding to other cities. And what we have seen, that once you cross the 20% failure of substation, then you are now drastically expanding the percentage of critical internet infrastructure that are failing. So we found that around once you cross 20% of the power substation failures, you will reach around 70% of failure on the critical internet infrastructure. So this is one example. It might be different, for example, to Germany or to Austria, or even to another country like South Africa or Brazil. But this is one case study that we did. So the key takeaway is that we see strong evidence of cascaded failure between power delivery network and critical internet infrastructures. And this is due to collocation. Many critical internet infrastructure put all their facilities in one location. We have seen many cases. For example, there was a fire in France where OVH, we had so many different facilities in one data center. So recommendations, we need to be working towards more internet resilience. So setting up standard measurement methodology, but also standardizing how we are producing our data. The Internet Society is doing quite a lot of effort on, for example, building a standard about fiber, but we see that they definitely need a standard about also producing information about power grid and transmission system. So thank you. That was my talk. I've gone over time a little bit. Sorry about that.
Yeah, thank you, Amadesh. I think it will be quite perfect with the time. So I think we can have a very short question, because we quite been at time only. But now we are in the break actually, so we can have like just a few questions. If you have any question from the floor or from remote participants, please hands up in the queue. No, otherwise, okay. So we have James.
Amish, do you mind sharing? Is there anything you can share on the Gaia mailing list? Well, we could put the presentation on the list, because I think there's some really interesting issues that you're raising there, and it'd be good for some of the community there to see that. Sorry for all the noise in my background.
Sure, Jane. Yeah, we can.
Thank you. Awesome. And thank you for the presentation. That was great.
Thanks.
Okay,
Dan.
Dan.
Hey, Manish, this is one of my projects, so it was awesome to see. A question: when you were doing that, when you're doing the thing about the distance from the power stations, did you look at anything like around how much backup capacity these data centers have, or things like that?
That's a very good point. Yeah. So this model right now is not taking into account how much backup capacity we have. So we are assuming that, for example, this is a prolonged type of failure where usually backup links would last maybe 1 day or 2 days. Usually they have like oil generators or something like that. But we are assuming that, yeah, there is no electricity, there's no backup links, and only email.
No, I
But
mean, and a great start. I love it that you're doing this work. So that's fantastic. Thank you for bringing it here and sharing it.
thanks, Dan.
All right, then I think so. We been finishing on the time. I might be just take this opportunity to just wrap up a little bit. So now, okay, we with the guy group, I think today we have a 5 presentation, very nice one. And then if you have any kind of questions or regarding about the talks, and then you can sharing out to the mailing list at GAIA and ITF. And also we also have the following up with the draft for Leandro. So we send out the call for adoptions to the mailing list. If you have any comments, just please feel free to propose, to sharing, exchanging email list, and then we're gonna move forward his draft to the next meeting. And also, if we will see you again, like in the next meetings in Vienna, IETF 126. So thank you very much for your attention for participants today. See you soon. And thank you for all speakers as well. Thank you very much. Thank you, Amrit. Thank you, Polly. Thank you. And thank you for Jane here for co-sharing these sessions as well. So
Thank you, Adisoran. Great job.
Thank you. Good to see you all.
Thank you.
see
Good
you.
to see everybody. Have a good afternoon.